Okay, let's get started. Good morning, everyone. This is a little early, so thank you very much for coming today. My name is Chigusa Sansen. I'm a product manager lead with Windows Platform and Developer team. I'm excited to talk to you about two of my favorite technologies based on XAML, because I've been working in XAML area for over a decade, and I'm here with Jeff, who I actually have known just as long.
Hi, I'm an architect on the Windows Platform and Developer team, and I've worked on all sorts of Windows UI technology, all the way from Windows XP's logon to Media Center to the composition APIs. I'm really excited to share how we're modernizing both WPF and WinUI, and how both XAML-based UI frameworks can build great Windows 10 and 11 applications.
And please use Pablo if you have questions. We have team members all across the world answering your tough questions. At Microsoft, we are actively investing in all these areas of ecosystem, from Windows native all the way to web and somewhere in between. You may be already using one of these technologies already.
On a lot of slides, you're going to see QR codes where you can learn more.
But please don't go there yet, because I want you to pay attention. I think it's an exciting talk.
Today, we're focusing on our two primary technologies for Windows native developers. We believe that both are great options, and by the end of the talk, you're going to know the strength of each.
So before we start, I want to ask the audience, how many of you are using WPF and WinUI today? Great. How many of you are developing apps that run on Windows, any platform? That's great. Thank you very much.
So today is part one. Tomorrow, we're going to continue our story with the BRK305 session at 1:15. It's on the other side of McCormick, all the way at the end of the hall. It's going to be great, because we're going to be continuing from where we started today and talking about how Office is using WinUp SDK, React Native, A/B development techniques, and it's going to be really great. Definitely recommend coming.
Both WinUI and WPF are great choices for creating Windows apps. They are both invested in and actively developed. That said, they both have strengths, and knowing that will help you pick the better choice.
So how about we get started with WinUI?
Yes. Today, WinUI is the technology of choice for most of our new features that we build on Windows.
We updated the fundamental architecture so that it's optimized for created native experiences on the latest hardware, including the new Copilot+ PCs.
If you need more flexibility in languages and CPU choices, WinUI supports all a variety of them. WinUI embodies Windows system design natively with built-in usability to support all input experiences you are expected to support on Windows.
So to get these full capabilities, you're expected to use WinUI 3. So you're expected to use WinUI 3. While WinUI 2 and UWP apps will continue to work, you need to migrate to WinUI 3 to take advantage of these new features. To assist in this migration, new for .NET 9, we have a preview of UWP support for .NET 9 to allow you to upgrade to the latest version of .NET first.
So I'm sure that the audience wants to see the demo, so let's get started.
OK. So our first demo, we're going to show you some of the places in Windows where we're actually using WinUI. And then we're going to show you how you can use WinUI Gallery as a really powerful dev tool to help you build your apps. We're then going to show it being used in both C++ and in C#. And then we'll show it running down level to reach all 1.5 billion Windows users where they are today. So we have these new Photos experiences that we've built into the gallery, inside File Explorer, and into the Photos apps. And these are really nice. This is a great way to be able to view your photos, and it's really smooth, and it looks really clean and polished, and definitely is a great example. So how did they actually go build these? If we look at the WinUI gallery, which is available in the store to download, then it's actually a really powerful development tool to see how this was done. We could go to the Items View control, and this looks sort of familiar. you can see what's going on with this new control that we've added that has great scrolling performance. It's customizable. All the different aspects of the animations can be integrated with. So it also is all open source. So we can go here onto GitHub. We can see the XAML for the markup that was used to create this page. And we can see the C# that was used for the code behind. So maybe we should use this in an app?
Yeah.
Does that sound good?
Sounds good.
OK. So I'll shrink these. And we'll go to, I think we have a camera app. And there was some usability feedback about it. Do you remember what that was about?
Yeah, so there is disconnect button that user clicks, and then it just disconnects without any warning. So it's jarring.
Yeah, you'd wonder if you lost your photos or something.
Right.
OK, well, let's go and address that. You're more of a designer between the two of us. Do you have any thoughts about what we should do?
Yeah, so I think we should use the dialog to give warning to the users, so if they want to, they have chance to cancel out.
OK. Something like this?
Yeah, and then we can simplify by removing some of those contents and removing the button so they disconnect and cancel. OK,
I have an idea of what you're asking for. I can expand here, and I can see the source code. This would be if I wanted to invoke the content dialog in markup. In this case, I'm going to invoke it in code. So here's the C# code to be able to go do it. I can go copy it to the clipboard, and I can go and switch into my dev editor. In this case, I've already made the changes in markup just to save a little bit of time, or in the code, just to save a little bit of time. So we're going to uncomment this, and let's walk through what it's actually doing while it's compiling. So it creates a new content dialog. It sets up the style like it got right from WinUI Gallery. We overrode the title and set the primary button. We got rid of the secondary button. And then when we do the show async, if they click the primary button, we'll go ahead and disconnect. So here's our app. And if I click disconnect and I say cancel, nothing's lost.
That's great.
And now I go ahead and pretty good,
it
right?
gives users the choice to cancel. Yeah.
Pretty easy. And then we can do the same thing in C++. So in this case, I have a C++ version of the same application. And you can see this is just using standard C++ 17. It's using our CPP Win32 tool to generate the Win32 projections. And it looks pretty identical. And so I can do everything in each language. I think there was something else we were going to show. Something.
Yeah, we want to show the gallery.
Oh, the down level. Yeah, the down level thing. That's pretty important. So we're running here on Server 2019. And this could have been Windows 10, any version. And we have, that's actually coming ahead, we have the WinUI Gallery fully implemented here. And you can see that content dialog looks and feels exactly the same. So it's the same version of WinApp SDK and WinUI that's running down level. The window looks a little different on Windows 10. What was that about?
Yeah, so we didn't have the rounded corners and some background mica, which shows the desktop transparency. So those things don't work on the older version. And
but all
that's
the stuff
handled.
inside does.
Yes, and that's handled by the WinUI and WinUp SDK.
OK, that sounds great. So we just showed the WinUI Gallery as a dev tool. And we showed using C# with .NET 8, and now .NET 9 just shipped, I think, last week. So it works great with both of those. We showed it using standard C++, and which is fantastic. So you have your choice of languages to use. And we showed it running down level to reach all 1.5 billion Windows users where they are today.
So one of the feedback that we receive is that WinUI is not so performant. Jeff, can you address this sort of an elephant in the room?
Sure. So we did a lot of work on performance the last several years. And you actually saw a bunch of that with the photos examples that we just gave. The new items view control has been designed for fantastic virtualized list scrolling that's fully customizable and being able to build these experiences. We also did work in things like flyouts and resource lookups so that things load faster on disk. Photos are 2.5 times faster than they used to be for app launch and for image loading, and it's a noticeable improvement. Finally, earlier this year with .NET 8, we also added support for ahead-of-time compilation. For a typical real-world app, it means that your app is going to be about 45% smaller distribution, and about a 50% faster launch time. The key thing with AOT is that you only pay for the code that you use. Since WinApp SDK is all written in C++, you don't have to pay any AOT costs for any of it. You only pay for your application.
And AOT is great, and we had a talk at .NET Conf that is linked here if you want to find out about AOT.
So let's say that I'm new to Windows development. Where should I start?
Yes, we believe WinUI is a great choice for somebody starting new on Windows. We made WinUI as a default option for new Windows apps in Visual Studio this spring, so it lets you get started at no time.
We also made some enhancements to the search experience in the Visual Studio installer to make it easier for you to find WinUI.
We improved File New Project experience so you can find recommended solutions much quicker.
And we improved support for WinUI's IntelliSense and build warnings to help you catch the errors up front. They're these features are already available in the Visual Studio preview, and they're going to be available broadly soon.
In WinUp SDK 1.7 Experimental 1, which is shipping today, we made WinUI title bar control available. We've incorporated a lot of community feedback, thank you very much, and it fully embodies Windows 11 design pattern with search boxes, custom controls, and proper input handling.
If you're not using WinUI, we also made the default title bar respect themes such as dark mode, and we're targeting this change in WinApp SDK 1.7.
Now that you heard what we think about WinUI, we want you to hear directly from our partners what they think of WinUI and also WPF, and why they chose one over the other. Let's take a look.
For Microsoft Photos, we chose WinUI 3 since it's a natural evolution of UWP. We can still use the beautiful UI controls from Windows SDK, and at the same time we will unlock new features and new possibilities, since now Photos is a full desktop application.
It's hard to hide my enthusiasm for building under WinUI 3. I've always felt that if you can build a native application, you almost certainly should. You're going to get the best performance, you're going to have full APIs available to you, and you can code your way to any challenge presented. Couple that with the power and elegance of XAML, and literally anything is possible.
Performance is one of the critical factors for enterprise applications. WPF, with its native code execution and hardware acceleration now through RDP as well, offers excellent performance for applications, particularly those that require high-speed data processing and complex UI renderings. While newer alternatives have made strides in this area, WPF's performance remains still a reliable choice for the enterprises.
Many other applications developed by Microsoft, but also developed by the community, are in a similar position where there's an application that people have come to know and love, and what's the best way to bring it into the future when it has a really long feature set. So with XAML Islands, we were able to replace parts of the app with modern UI, while not bifurcating the app experience and having people need to go into either something new and wholly different, and then occasionally needing to go back into the old application when the new app wouldn't have some feature that they would need.
At the time, we took a fresh look at the options we had and considered approaches with Electron, with Qt, and with using Rust and Swift. I'm really pleased that we recommitted to C# and WPF. We've been able to move rapidly with 𝗬𝗲, brought a number of innovative features to Windows, and above all, we haven't been surprised. Well, maybe we had a few surprises. ARM support was so easy that it was nearly free, and our path to supporting NPUs was easier than I anticipated. The surprises have been positive. C# and WPF are robust, mature, and well supported. We've been able to focus on building our product rather than wrestling with frameworks.
We are so grateful for partners and community willing to work with us through trials and errors. We will not be here today without your support. Thank you.
Photos, File Explorer, and 𝗬𝗲 all chose WinUI to align closely to the Windows system and take advantage of being native.
Partners like Morgan Stanley and Reincubate, who has huge existing investments with WPF, chose WPF for its reliability and maturity.
So far, we've learned about WinUI. How about we dive into WPF?
Let's do that. WPF has been around for many, many years.
WPF has a vibrant ecosystem with rich middleware over many apps. It has great documentation and tutorials that have been built up over many years.
WPF also has rich .NET support since the framework itself is built with C#.
We want to meet you where you are with thousands of lines of code that you've already written. Whether writing a simple app, line of business, or client-server heavy apps, if WPF is serving your needs, there's no need to switch. We want you to confidently invest in WPF. So with that, let's give our next demo. We're going to show the WPF gallery, which I think we got just an accidental sneak peek in a moment ago. And we're going to show how easy it is to go and take an existing WPF app and to go modernize it so it has a great look and feel on Windows 11 and 10. So, all right. Okay, and we'll just start that up, and there. Okay, so here's the WPF gallery, and you'll notice that it looks very similar to the WinUI gallery. And it has, we've basically gone through, and this is all now shipped with .NET 9, which just shipped a week ago. It has all the different controls, and they've all been updated to have the standard Windows 11 look and feel. So with each one of these, you can see there's the source code for how to be able to go use this, and this is all open source, again, up on GitHub. So how can I actually use this in a real app? So in this case here, I have the calculator app, and all that I've done, I'll get to that in a second. All that I've done is I've downloaded it off GitHub, and I spaced out the buttons a little bit so that they weren't quite touching. But it's looking, what's the word, very?
Great.
Yeah, it's very great.
Yeah, it needs to be modernized a bit.
Okay, let's go spruce this up. So it's actually now really easy. We've added support from when we previewed this earlier in the spring. And you can now use this new theme mode. And so I'm going to go and uncomment this and get this to work. And so you just say the theme mode equals system, and that's going to go and bring in the new fluent themes that were added with Windows 11. And it will apply it to all your controls automatically.
That was pretty simple lines of code.
Yeah, it's just adding an attribute in your app. And
Yeah.
that looks
good.
pretty good, right? Yeah. So, yes, and then I think we also wanted to show it running down level.
Yes.
Yeah, okay, let's do that. Okay, so here we are. We're back in our Server 2019 VM, and you can see that it is the same WPF calculator, and it's now running with the new look and feel on all Windows 10 and 11 computers.
Yeah.
So this is really great.
Yeah, as you notice, this is also handling, I don't know if you noticed, but the accent color is not using the purple that was on the other.
Oh, right.
Yeah.
Yep. That is right there. Okay. So we just gave a quick demo of the new WPF gallery and the new Windows 11 theming that's available with .NET 9. We took a WPF sample that was just on GitHub, and we showed how easy it is to apply the theming. You might have to do a little bit of layout changes and stuff like that, but it's pretty easy to go and apply. And then we showed the app running down level on all 1.5 billion Windows computers.
So let's summarize what you have heard so far. We recommend WinUI if you're building new app or would like your app to be aligned closely with Windows system.
And WPF is a great choice if you've already invested in WPF and you love the rich ecosystem with it. So after giving these talks for a few years, we've heard that there's some challenges.
Yeah, so I hear that these stories that we tell sounds great in theory, but it doesn't work great in practice.
What do you mean?
Yeah, so for example, most devs cannot rewrite the whole entire app all at once. Like Office, who we have a session tomorrow.
Yeah, it's going to be great. Please come.
Also, apps must support multiple OS versions with the same behavior to reach most of their customers.
I've also heard that apps like Office and other large apps need to have control of their dependencies when the dependencies update, and this is a real concern when they're calling OS APIs. So when we step back and we look at the larger Windows app ecosystem, Most people are familiar with the Windows Platform SDK, which provides APIs that are determined by the version of Windows that's installed on the machine. If you want to call newer APIs, the user needs to be running on a newer version of the Windows OS. We also have the Windows App SDK, which provides APIs that are determined by your version of your application. We lifted the modern app stack into your specific application and created your own virtualized instance. If you want to call newer APIs, your app uses a newer Windows App SDK, and the same is for other libraries and components. You can tell the difference. The Microsoft APIs are part of the App SDK that's determined by your app. The Windows APIs are part of the Platform SDK that's determined by the OS that's installed on the machine.
So what you're saying is that app developers using WinUp SDK get the specific benefits.
Yes. So one of those is that WinUp SDK was all designed around incremental adoption. And we're going to go into this in a lot more detail in our session tomorrow, because an app like Office can't be rewritten overnight. It makes it much easier for large apps to modernize and piecemeal updates, and they can also integrate modern content with their existing UI content.
And WinUp SDK prioritizes predictable consistency. This provides the latest Windows app functionality everywhere down level, all the way to Windows 10 RS5 and Server 2019, without any OS servicing, without IT admin updates, and is fully side-by-side.
WinUp SDK also supports apps choosing the timing of when to update to a newer WinUp SDK release. Developers get a new WinUp SDK, they validate their app, and then they explicitly move forward.
So I've heard questions like app must be packaged or MSIX or be in the store to use WinUp SDK. Is that true?
No, that's not the case. We recognize that developers don't want to rewrite their app installers. So what is this all about? So let's talk about packaging. Packaging and using MSIX makes it easy to use WinUp SDK, but it's not required. Unpackaged apps can fully use WinUp SDK both as a framework package or as self-contained distribution. They're both fully supported and documented on learn.microsoft.com.
That's great to hear that I don't have to package my app or publish it to store, but it provides benefits to if I do.
Yeah, let's go through some of those. So first thing about packaging apps is that it gives your apps identity. This is really important for certain Windows APIs like Share Target and notifications and the new Windows Copilot Runtime APIs that are integrated with privacy and security, along with camera and location. We want users to be in control about whether they give an app permissions to run certain features. Finally, packaging also gives your app measurably faster install times and completely clean uninstall. So we use it because it has a lot of benefits, but it's not required. So with this, let's go to our next demo where we're going to show how easy it is to actually go and take our WPF calculator app, and we're going to go make it packaged. We'll add a dependency on WinUp SDK and then call some APIs. So let's get started. All right, and we'll bring calculator back and right here. OK, so this is exactly where we left it. And so the first thing to do to go create a package is that I'm going to go add a new project. And I can just type MSIX in here. And I can see a Windows application packaging project. And I click Next. And I would type my packaging, the name of the package that I want to use. In this case, I've already gone ahead and created it just to save a little bit of time. The key thing with a package is that it needs to know what app to actually deploy and install and launch at startup. So we do this by going to dependencies, and then we add a project reference, in this case to our calculator demo app, and then it will know what to include in the package and what to launch. And then we change, instead of running the previous app by itself, we change to running the package, and we run it. And we shouldn't see any differences in the app itself yet. It looks exactly the same. The key difference is it's going to show up in the add remove programs because it's now being installed rather than just merely being run. So
That's
it looks
great.
the same.
Yeah,
Yeah.
that's great. But there was a usability issue with this that I want us to fix here.
OK, so let's bring in WinUp SDK to be able to go do that. So we're gonna do a few things. So WinApp SDK, because it's a bunch of native components, we have to go and set the processor architecture types to ARM64, x86, and x64. And then those are the modern processor types that we support on Windows 10 and 11. Remove the any CPU and the legacy 32-bit ARM because you're now deploying completely native components and the package needs to know which to go and install. There was something with the calculator demo itself that we needed to do. What was that? Something in properties?
Yeah, at the target.
Oh, right. So we go to the application and we specify the supported OS version has to be 17.763, which is RS5. And that will make it run everywhere that we need. Okay, and then...
NuGet?
There's the NuGet package. So we're going to go and we have our NuGet package here. We have WinApp SDK. And then we add it to both the application itself and the package. By adding it to the app, here we'll show this right here. By adding it to the app, that allows the app to call the APIs. And by adding it to the package, that allows the package to automatically deploy it and install it as part of the app install. So, and that's fully integrated in. So now I think we were going to go and hook it up all manually.
Yeah, so before you start though, let me explain the usability
What is
issue.
the,
Yeah,
what
so
was that?
when you have the calculator app, and if you click out, it goes back.
It hides behind.
It hides behind. So
Yeah.
I can't really work multitasking.
Okay.
So I want the calculator to stay on top so that I can do that.
Sort of like
And
video playback.
yes, and then
Okay.
we want to use the WinUp SDK compact overlay API for that.
Okay, that should be pretty easy to do. Now remember, we haven't done any explicit integration into our WPF app or into WPF yet. So we're doing this all old school by hand. This is a place where it'd be great to go and add new features in the community toolkit or in WPF to make this easier in the future, but you can do this in any app, in any framework as it is right now. So we'll go through those different steps. The first, what we're going to do is on the UI thread, we need to integrate WinUI or WinApp SDK's notion of a UI thread with WPFs. And so we do that by creating a dispatcher queue controller, and we're just going to create it on the current thread. And on our WPF app, when it exits, we'll just shut down that queue, and we're going to be good. We're then going to also go into, we're going to add a menu item to enter your compact mode. So, and we have an event handler here that we're going to go fill in a second. And then we have some layout. And what this is going to do is we're going to change our WPF elements in the window around to make more sense when you're in a compact mode. So the compact mode changes the window and behavior, but it doesn't change what's inside the window. So we'll just make it a little better. In our main window, here's those two event handlers that we've had, and they call a common worker function. From this, again, because there's no automatic integration that we have right now, you can get an app window, and from the WPF window, you promote the WPF window into an app window, which will then allow us to call app window APIs on it. This is then going and changing our WPF elements around a bit to change what's actually being shown when you're in compact overlay mode. And here's the key of the thing. It's calling the new APIs that are on app window. This is what actually enters compact overlay mode, and it sets the size to 400 by 400 in view pixels. And then when we're exiting compact overlay mode, we'll restore back our original WPF elements, and we'll just go back to default. We now need to go and add all these files that we just talked about. So we're going to add these ones right here, I think. And then we'll start running. And are you feeling lucky?
Yeah. I always feel lucky.
First thing in the morning, you got to be lucky.
Yeah.
All right, so it's building away, and then we're going to see if this actually works.
So that people can see what I was talking about when it launches, I want you to click out.
Okay.
Yeah.
Yeah, so we click here. I see what you mean. So we really want to be able to, like, let's say I go and enter compact mode. There's this new compact mode. I've moved it here. If I click here, it now stays on top. And when I restore, it returns the window back to where it was before. And it also changes the Z order behavior so that it's no longer topmost. Yep. So that was pretty easy.
Yep.
So, and good call. So we just gave a quick demo of taking our existing WPF app and showing how easy it is to make it packaged. WinApp SDK fully supports packaged and unpackaged apps. You don't have to be packaged to use WinApp SDK, but it makes everything a lot easier. Packaging also enables APIs in Windows, like share target and notifications, and it makes it easy to set up and install your dependencies. The key thing to use WinApp SDK is that you need to target your app for Windows 10 RS5 and later, which is the build 17.763 that we showed. You also target the specific processor architectures for x86, x64, and ARM64, and you remove any CPU and the 32-bit ARM. You add WinApp SDK as a NuGet package to both your app and the package. That will allow you to call the APIs and to deploy WinApp SDK as part of your installation. And then finally, you call the APIs and you're all good to go.
Sounds great.
So let's talk about what's in WinApp SDK. Like we just used this app window functionality that's part of the islands and Windows stuff that we're using, but there's a whole bunch of stuff. The WinUI stuff that we talked about earlier is part of WinApp SDK. We also have the scene graph that's powering WinUI, and in tomorrow's talk, we're going to show how it also powers this new framework called React Native, and it's unified altogether. But earlier this year, I think a lot of people are interested in the Windows Copilot Runtime APIs that we added to Windows App SDK. So let's talk about them a little bit. Win Copilot Runtime makes it easy to develop AI apps on Windows that are efficient to download and run across multiple applications. We have over 40 optimized models for your specific hardware. The first wave will be available in January 2025 with WinApp SDK 1.7 Experimental 2. It will include the 𝗲𝗬𝗀𝗀 small language model, OCR, image APIs, and more. It also will have support for PyTorch and WebMN.
So are there any sessions that they can find out more about this?
Yes. There's actually a breakout session tomorrow morning, BRK305, that's at 9:45, about integrating AI in with your enterprise apps. And there's a theater session today, Wednesday, at 2:30 about getting started with the Windows Copilot Runtime. We recommend going to both of them. We've been showing a bunch of UI things in our demo, so let's continue doing a little bit more UI things, because I think we have some exciting stuff.
Sounds good.
Okay. So I think for our big demo at the end, we're going to take a look at the scene graph that we talked about that's powering WinUI and React Native and give sort of a taste of the full expression of what it can do. Does that sound good?
Yep.
Okay. So in this case here, I'll get things ready. And all right. Sweet. So I have here a pure C++ app. It doesn't use any UI frameworks or any other dependencies. It's only calling WinApp SDK APIs. And this is the equivalent of what would have been a C++ Petzold Hello World application. So it's actually pretty simple. It goes and creates that dispatcher queue controller that we talked about earlier. And then it goes and creates an app window to get something on screen. When the window closes, it's going to exit the message loop. It sets a title, shows it, runs it, and all that. And so that would create a window, and pretty easy. We can do the exact same thing from C#, and it's the exact same APIs that we're calling. Again, there's no UI framework involved here. And so this will go create a window on screen. But I'm guessing you're not going to be happy with that, because it's going to be sort of empty inside.
Yeah, so
what do you want to put in it?
yeah, I would like to see if we can put 𝗦𝗲𝗲𝗶𝗍𝗍 in there to get some animations going.
All right, let me see what I can do.
Okay.
right.
For those of you who don't know what 𝗦𝗲𝗲𝗶𝗍 is, it's a JSON-based animation format widely used by the design audience. We also use widely on the Windows system, like taskbar, to get many places to come alive. And just like that.
Yeah, so this is the default 𝗦𝗲𝗲𝗶𝗍 animation, and it's being used from a C# app. We used C# in this case because the 𝗦𝗲𝗲 file parser up on the community toolkit is all written in C# to do the file parsing, and it works pretty well. And I'm guessing you want more.
Yeah, I would like to see this in the UI framework, even though this is frameworkless and it works everywhere.
Okay, what about if we put it into our WPF app? Would that be good?
Okay.
All right. All right, back to calculator. calculator this time. So in this case here, what we have is a little bit of helper code in WPF to be able to go and connect to some external content. And the WPF goes and does this using a child 𝗬𝗏. The scene graph itself does not require 𝗬𝗏s. It's all composition-based, and so you don't need to use it, but WPF does use 𝗬𝗏s to be able to incorporate it. So this is pretty standard WPF hosting code. We then also have the 𝗦𝗲𝗲 code that all that this is doing is creating that 𝗦𝗲𝗲 island and loading that 𝗦𝗲 file to go and get parsed and creating the objects. And then we're going to go and again add some markup. And we have our, this is the real code. So when you click the menu item, this is what a typical user would actually write if the community toolkit, for example, had the helper stuff written. They'd go and create the WPF island host to connect the external content. They'd go and then create their 𝗦𝗲𝗲 island that goes and has loaded their 𝗦𝗲𝗲 file. They'd connect that island, they'd connect the host into WPF, and then they'd go and connect the island into the bridge that we just created. So let's go and add these files into our project. And so island host, 𝗦𝗲𝗲, main window, add. And we're going to go run this. So if this is working right, what should we see?
So 𝗦𝗲𝗲 inside the
Yeah,
calculator,
𝗦𝗲𝗲 inside
right?
calculator.
So just to tell you that we're not expecting you to create a calculator with 𝗦𝗲𝗲 in it, but we want to show you this as an inspiration for your app to come alive, right? So
Yeah.
just you could imagine that section having something.
Yeah, so it's working pretty well. So there it is, 𝗦𝗲𝗲 inside WPF, without any WPF changes, without any explicit WPF controls, and without any Win App SDK new features. You can do all of this today. Pretty cool.
No, you want
But
to
now I'm wondering if we can do more.
Yeah.
Okay. All right, let's do just a little more. So I'm going to, I'm going back to the WinUI gallery, and these islands that we just showed for 𝗦𝗲𝗲, I can actually do even more with them. So I've gone and hooked the islands back up into WinUI so that I can go and I can go load the 𝗦𝗲𝗲 in WinUI. This is without any explicit WinUI 3 support. But then I also can go and take advantage of the 3D rendering engine that's powering our whole scene graph. And so the key thing here is that these scene nodes that we're using to do the 3D rendering, this is all using advanced DX11 and 12 per pixel lighting. These models are very efficient, much better than the older 3D rendering that was available in WPF. And so it's actually very powerful and flexible. And you could, for example, use this to render charts and avatars and other things in 3D worlds inside your existing apps without having to rewrite all of them.
Yeah.
It's really cool.
Yeah. That's so great to be able to modernize
Yeah,
parts of the
incrementally.
Yeah.
And we're going to show that more again with Office tomorrow about how they're actually using all this. So we just gave a demo of using Win App SDK directly in raw C++ and C# without any UI frameworks. We showed that the scene graph that powers WinUI, and we'll talk about React Native tomorrow, can actually be used in any framework and in any application. We gave examples with 𝗦𝗲𝗲 and our 3D scene nodes and more, and it's all running down level all to 1.5 billion Windows users today.
Today, we are releasing Windows App SDK 1.7 Experimental 1 with many of the functionalities that will enhance your app's experience.
It also includes some of the APIs that are needed to migrate your app from UWP to WinUI 3 like OAuth.
And we have Experimental 2 coming in early next year that will include 3 of the Windows Copilot Runtime APIs that's listed here.
The Content Island hosting is something that we continue to improve release over release, and it's already available for you now.
So let's wrap it up. Today, you learned that WinUI is a great choice for starting new to build apps aligned with visually and functionally to Windows system.
WPF also supports modernizing your Windows investments with a rich ecosystem and very stable platform. It has great C# support. You also learned that either option you choose will allow you to take advantage of the Windows App SDK without rewriting your whole app.
Both WinUI and WPF have the ecosystem support you need to make your app creation easier. And as mentioned, WPF being the richer of the two, with WinUI growing.
Now we want everyone to go out and build Windows apps. Please give the updated Visual Studio workload a try for WinUI. Apply theming with the new .NET 9 to your WPF apps, and share places where you can use WinApp SDK and give us feedback. Don't forget to use the WinUI and WPF Gather apps. They're both available in the store for easy install, and they're very powerful dev tools.
We want you to join the Windows developer community. We have a YouTube channel where you can learn about AI on Windows, client platform how-tos, and developer tools and tricks.
We also host a Windows developer chat and WinUI community call where you can learn and ask questions about building your Windows apps.
And our next dev chat is scheduled on December 12th, and WinUI community call is on January 22nd. We hope you can join us.
Check out Dev Center, and you'll also find the latest information. There's several sessions that we recommend, especially our part 2 that we've been talking about, where we're going to examine about Office, React Native, and large apps on Windows, all supported by WinApp SDK.
And we have a lot of resources for you to build great Windows native apps. We cannot wait for you to get started.
Please fill out the survey and tell us what you found useful and what we should incorporate more of in the future. Thank you both.
Thank you very much.